And in the procedural tab, we want to right mouse click and go to Edit Function. And now we can see something a little bit different than what we have in the material editor, at least for our function output observer. And that is we can actually see the terrain that we're working on, which is very helpful. We have a couple of options for this. We can turn on Fit Vertically. And typically you're going to want to have that turned on if you're going to be modifying terrains, because this does look more like what we're actually going to see in the scene. And when Fit Vertically is off, it's much more smoothed out, more even, and it's not necessarily going to look the way it does with the actual object. So we'll keep that turned on. We're going to take a look at what is generating this terrain. Right now we just have a simple fractal, and it has some very basic settings. And this is the same fractal that we're using with the other types of nodes for the material. And all of these are the exact same types of nodes used back and forth. And with terrains, we're just not working with color. And our output node goes to our altitude, and we're generating our altitude based on the white and black values, white being the higher points of the terrain and black being the lowest points. Now if we want to match this up to the size of the terrain in the scene, we need to change our scale in the output observer to 0.5. And because we're using a simple fractal, we have a lot of definition and a lot of detail creating our terrain. So what we can do is just turn down our roughness all the way if we wanted to achieve the effect that way, which is one good way of doing it. Or what we could do is replace this with a noise node, and we could just add in a noise node and attach that. So now we could generate a terrain entirely based on that noise, which is a very smooth surface. Just as you could see with the materials before, we have a very smooth terrain. The only thing is we don't have that largest and smallest feature. So whether or not you'd like to use the noise or the fractal really depends on how much variation you want in your terrain. You could of course use a combiner node and have two different types of noise nodes to create the overall altitude. But what I'm actually going to stick with is just our simple fractal. Instead of the noise, like I said I was going to replace it with just the lower roughness value. And we have another type of fractal we could use too, and that's just a basic repeater. And now a basic repeater is going to work almost exactly the same as a noise node, except that we have a few more options for modifying some of these settings. I'm going to go ahead and create a noise so we can kind of go back and forth and compare. But basically, with the noise, we do have the ability to animate this. We can change the scale, the wavelength, the origin, and set whether or not we'd like it to be rigid, and then we can see those areas showing up on our terrain. But basically, we go back over to the fractal, and even though the basic repeater looks about the same, we'll go ahead and we can switch that over, and now you can see that rigid better because I didn't have that connected. We still have a lot more options where we can adjust the amplitude, how many times we want it to be repeating the harmonic behavior, and then the overall scale of that harmonic behavior. Our combination mode, which gives us some really interesting looking effects, and we can get some pretty neat looking terrains. And we can also set a filter. Now the filter option isn't a huge improvement just because you can always add a filter in with the link, but we do have a min and max value for this filter, and it is directly tied in to our fractal node, so that can be very helpful. Change that back to our simple fractal. We could also go to a fast Perlin fractal. This one doesn't have as many features as we have with the simple fractal. We don't have a lot of the options for modifying it if we kind of just switch back and forth, you can see our filtering is completely gone. And we also don't have the ability to adjust which noise setting we like to use. It automatically uses a Perlin fractal, Perlin noise, basically the gradient, which is the default. But I'm going to remove that noise node. We're going to use our simple fractal, change our wavelength down to about where we were before, and then we can decrease that roughness. And that way we have very little definition in our terrain caused by the node itself. And that way we'll really be able to see the bump map that we're going to be setting up within the material. So we'll stick with that. We can click OK. And that will be added into our scene. I'm just going to reposition our camera. And now we can see we don't have nearly as many slope ranges as we had before. I'm going to go ahead and stretch that up, making sure we're on the scale part of the gizmo. And I'm actually going to go ahead and increase that roughness a little bit more, because I don't think it's really showing the full definition and maybe what we need to generate the type of terrain I'm looking for to show you this a little bit better. We could just increase that roughness a little, but mainly I want to add a filter to this. And if we use a sine wave, then we can start to cap out the peaks. We can always adjust that contrast and the brightness value. And that looks pretty good right there. And click OK. And now we can see we have some nice slope ranges, but nothing that's really going to throw off our material. So let's go ahead and render this really quick without the bump map on, and we can see what it looks like. And then we'll apply the bump map to the material, and you'll be able to see all the definition that we're going to be able to pull out of that. And we can see a very smooth surface. And we might need to increase that overall size of our first input, which is covering our steeper areas of our terrain. And maybe we could modify the color a little too to offset that. But what we're going to do first is add in that bump map, and you'll really be able to see the detail, and it'll look a lot better. So we'll go into the function editor. And all we really need to do is take our bump connection from our output, and you can see that we currently can't connect this to our blender, and that is because our blender is connected to color inputs. And a really easy way to tell what you can link things to is the way each of these links is colored, and we have different colors for different types of inputs. And basically, our green is going to be color information, and our blue is a number-based input, or basically our fractal nodes and different types of filters and noise nodes. And those are all going to be based on the blue inputs. And we can see that the bump is a number-based, along with a lot of our top input nodes that we have, were altitude, slope, orientation, and time, and those are all based on these positional inputs. And of course the connection up to our texture maps also is, but the main thing is this blender is a color map, which we can see with that green link. And we also have two other colors, basically our purple, which is texture coordinates, and we can see that is linked to our scale right now, and also our image offset. And then we have the origin, which is showing up right now as a red link, which is vector data. Now typically if you're working with a fractal node, we can see that same sort of an effect where we have the wavelength and the origin, connecting to our position with a red link. So then we can connect the center output, which is our origin, directly to the position and the normal, but we will not be able to connect our purple links, which are texture coordinates, to these specific input nodes that we have right now. And that can change and vary depending on what it is you're working with. Certain types of filters and math nodes will only work on specific types of inputs. Some of them will work on both, and you'll be able to see that once we start adding those in those areas. But it's definitely just something to keep in mind, especially too because if you worked with a previous math node or filter node that did not connect or is not compatible, and you create a new one with the link selected and it doesn't add anything, that means not that you can't use that specific node, but that you will have to change the parameters. And let's go ahead and take a look at that right now. I'm going to add in a math node, and we can see we have a blue link, but I want to change this to something that is going to be not compatible. So our math node is set to sine, and as we start moving in to select other options, we can see that a lot of them become grayed out, and basically that's an undefined data type or it's just not compatible. And in this case, these specific types of math nodes are not going to be compatible with a number-based input or output or the blue links. So if I was to change this to one of these, it won't let me. So let's go ahead and do that outside of it. Create a new math node. And we'll just change it to something that I know is not going to be compatible. Delete that current sine wave. Now if we select our math node, and View always remembers the last one we had selected, so when we create a new one, it will create the same one. If I select our link now to our slope and go to add another math node, it's not going to let me. It's not going to create anything, and that's because it's not compatible. But that doesn't mean math nodes in general aren't compatible. Just that specific one you had selected last is not compatible. So we could change that to a floor option, and now if I select the link and create a new math node, it will work. So sometimes you just have to create them outside of the link and then manually connect them up to your input nodes or output nodes in order to get what it is you're looking for. And so basically we need to figure out how we're going to connect our bump using these exact same textures, because we do want to have it set up exactly the same way. Well, what we can do is, since combiner nodes work with both color and position information, we can create a new Blender combiner node, which is exactly the same as the other one we have. And then what I can do is connect our inputs, and we're going to be using the grayscale information, just the same way it's already set up to the other Blender, and then connect our ratio to that slope. And this really isn't a disadvantage at all, having to create a new Blender. And the reason for that is we can define new filters, because we don't want to have the bumps to be exactly the same amplitude for both of them, because if we take a look at the first input, which is showing up on the bottom part of our slope, it's a little too defined, really too much amplitude on it. So what we can do is select our input for that and that connection link, and we're going to add in a filter, and we could just tone it down, and that way it's not going to be as intense as it is previously. And then we can also do the same thing for that top one, whether or not we just want to use a regular filter or a partial filter, or setting up one of the presets that we have, like the sine wave we can see showing up. I'll change that to a regular filter, and you can see sometimes the links will break off when you change it, but all you need to do is reconnect it, and then it'll work out okay. And we can just tone that down. and I want to make it a little more gray, we could just click and drag all the way to the lower left, create a new key point, and then move up that side. And that way this part's going to be a little bit higher, but it is more grayed out. We could also use a gain filter to create that sort of an effect. And then if we take a look at the final output of our bump, we might actually need to create a little bit higher of a point for that filter so we can see it just a little bit better. And if we go to our bump, I'm going to increase this just to 1.5 right now, and we'll take a look at the overall surface with that value, and if we need to, we can decrease it or increase it depending on how it's going to look. So now we have a bump map set up, and we can go ahead and render this out and take a look. And we can see with the final render, it looks fairly bad. it doesn't look right. There's a lot of problems. Mainly that's the amplitude of our bump. So what we can do is decrease that overall value, and we can start to fine-tune it a little bit better. We'll go into our bump, and I'm going to turn this down, starting with 0.3. And then we can vary it and change it, just kind of adjusting until we get it to look right. So we start with 0.3. If that's too high, we can tone it down. If it's too low, we can start bringing it up. So I'll go ahead and render that again, and we can take a look at the newer bump map setting. And we can see this one does look a little bit better, but I definitely think the upper surface and the one on the flat areas and not on the slopes does need to be increased a little. The only problem is with this image map and the way we're using the exact same image for the color as we are with the bump, and typically what you want to do is have a modified bump map, which I could load in, but we don't always have a bump map all the time, and sometimes you just don't have time to create it. So there are different ways we can modify to make it to look realistic and correct without any tiling effects and without too much graininess or little sharp values showing up in specific areas. So I do want to increase just the upper value and not the lower one. So what we can do is modify the filter for our bump on the upper value and just increase that right point that we have. We could also make this into a curve and have a little bit of a slower nonlinear descent into our top values, and I'll bring this down a little bit more too so we can have some lower bump value. And I also want a little bit of variation, so I'm going to use another combiner node and actually combine this texture that we have with a fractal node, because we can easily combine both textures and fractal nodes together to get some really neat looking effects. So we'll add another blender on top of our current blender, and you can start to see some of the problems I was talking about before by using the straight lines versus the bent ones. So I'm going to turn this onto straight lines just so that we don't have our nodes all moving around on us. And sometimes the other method can look a little bit cleaner, but it really depends on how many functions and nodes you're working on. So now we're going to add in a simple fractal, and I'm going to change this to just a fast purlin. We can adjust our largest feature, bringing it down, and also change our wavelength. We're going to bring our wavelength down to 0.2. and actually maybe 0.5, so we want something a little bit larger, and that way we have some more variation. Increase our roughness, and then we can connect that blender. So now we're going to be blending both the image with this fractal, and that way we get some size variation and height variation, but still have the definition that we want because where the image map is. So if we could change that ratio between the two, change one of our combination modes, changing that to add should work quite well. And I'm not going to worry about controlling that with another fractal node, just because this should work out really well, just that simple blend with the combination mode set to add. So let's go ahead and render that out so we can take a look. And we can see that definitely looks a lot better than the previous render, but still we don't have some of the definition that might be needed in order to really make this look good. But rather than just playing around with this and not really covering a whole lot, we're just going to make a few modifications and then go right back into modifying the function. So I'm going to go into the function editor for this and just increase the roughness. And we'll take a look at how that's going to look. And now we can see that looks a little bit better. But I want to take a look back at the material for this so we can modify our color a little. Because right now it can be a little bit difficult to tell the differences between the materials. And I also want to modify the atmosphere just a little because it can be a little difficult to tell the brightness value. And even though our preview looks a little bit different, it's not quite rendering like that. So we're going to increase and go more towards a sunlight value for our light balance. And that should brighten up our scene a little and also increase our light intensity a little. And then we can click OK. And that looks really bright, but it should render out a little bit darker, mainly because of the bump. That does play a large role in how that is being darkened. So I'll set this to 0.25 for our bump production. We're going to go back into the function editor, and let's take a look at modifying some of these colors, mainly with our first input. So we're going to select our green color link between our color blender and our projected texture map for our lower areas. And I want to use a color map for this with color correction. So we're going to add in a color map first. And I'm going to change this to color correction. And now we have all of these different options to change color. Let's go with the Hls Shift, which is going to give us hue, luminosity, and saturation values. And we'll also take a look at some of the other color correction modes. But first, let's go ahead and just connect what we already have with the Hls Shift. And now what I can do is change our hue. If I wanted to make this a little bit of a different color, maybe I could increase our luminosity, brighten it up a little, or I could make that color a little more intense. And all we got to do is just increase that saturation value. And if I allow luminous colors, it's going to go a little bit more beyond some of those saturation values we already have. But I'm going to keep that turned off, and I just want to increase that value. And now we can really see the difference between these two different materials. And we can definitely see that showing up in the preview. And I'm going to render this out just a little bit smaller, and we can take a look. And with that color change, we can really see that value, and definitely the differences between these two surfaces now, and they're not blending together as much as they were before. But let's go back and take a look at some of the other color node options that we have, and different things we can do for color correction, because it's fantastic and just a great way to be able to do this directly within View, rather than having to go into an image editing program and modify any textures or anything you might be working on. So we sort of have an image editing program built into the function editor just by using these different color correction options. So there's just so much we can do with it. I'm going to change this to our Hls Color Shift, which works a little bit differently. I'll go ahead and connect that. And what this will do is allow us to select a color that we're going to be changing it to, although it doesn't necessarily create a direct connection and direct link to that color. So what we can do is go ahead and change that to a blue, and now we're going to see green. So it's almost an opposite effect. If we go into green, we get more of a purple. And we start getting towards the lower saturated values, and we can see it's getting a lot darker. And there's also some purple flecks that are showing up in different color changes. We change that to that color blue, and now we see more of a green. So for a lot of your fine-tuning, typically I would recommend just the regular Hls Shift. It can be a lot easier to use, definitely much more predictable. But we can use this one to extract our color, and you can see it is a green link, so we have something a little bit different. And I can connect this to our projected texture map, and we can change the color that way. I am going to change this mapping mode to faces for this first one, and that way we don't see all that stretching, because normally that wouldn't show up in the lower areas, but in this case it will. You can also see a bit of a seam in here, and that's being caused by the fact that we're using the faces mode, because it does apply on different areas, and it doesn't always match up. But overall, I think it still looks really good. And you can see that color shift has definitely changed the overall look of that other material that we had. We could also connect that to different types of color maps, where we can use a gradient map. And I'll load in our green purple, and now we can connect the shift directly to that. And if you take a look at the top, we have a blue function. So we could control this color map with different texture maps, or we could connect it over to this fast Perlin fractal. And now we see much more variation in color, and of course some different blues showing up, and just because of the way it separates and does sometimes more of an opposite color. And right now we have that green in there, which actually looks kind of neat, but it's really not what we're defining. Go back to the Hls Shift, and we can also define these values by using the fractal nodes, and we can adjust the hue and shift that way. So if we wanted to make a little bit of a color variation, we can add in a fractal node, and I'm going to connect our top input, which is our hue, to this fractal, and now we can see all the different hues showing up because we have the black and white value, and those are working from different ends of the spectrum, white being one side of the spectrum and the black lower values being the other side of the spectrum. And if we want to tone that down just a bit, there's a couple of things we could do. We could decrease the gain, and that will give us a very slight amount of color change, depending on how much we're really looking for. Because right now we're moving into purples and pinks, and it doesn't quite look right. And you might have to go with a very low gain value in order to get it to look good. So what we can use instead of that, and just bring our gain back up, decrease our roughness, is set up with a filter, and then we can easily modify this filter to go more towards the bottom. And now you can see the values that we're setting now are not as sensitive, and we're not moving into the other colors until we get much higher in this point value of our filter. So once we're towards the bottom, we're really just slightly changing that color variation just through different amounts of green, and we're still within the same color, and we're not worrying about getting into undesired colors, and like we were seeing before, that mix between the different colors. And we can adjust the saturation in that method too, and also our luminosity. If we go ahead and attach the saturation value, we can see it's very gray. We're not really seeing a whole lot of color anymore. So in that case, what you'd want to do is have another filter specifically for that link. So now we've created a new link. We can add a filter in there. And this is going to work kind of the opposite. And if we bring this right side up, we notice the green patch is showing up. And then the left is going to define our lowest saturated values. So basically, this right point all the way on the top is the brightest amount of color. And if we just click and drag all the way down to the lower left, so we have a -1 on the, or sorry, yeah, -1 on the X and a -1 on the Y. We can create a new key point and then start to modify that saturation value from the lowest points, and of course bring that up really high if we wanted to have a very high saturation value. So if we don't want to go in completely black and white, we would want to have this set to at least around here in this case. Maybe we could turn that on to curves, vary that a little, move to the other side, and we could bring that down. And now we have bits of green just showing up, and not a complete gray value, but we do have a little. And we could always add a new key point in the center and adjust our curves that way. And you can just get some really interesting looking effects by using these different filters. And this is just the straightforward filters. Basically almost manual, if you think about it like that, rather than something that's going to be generating itself based on the values that are already embedded in it. And I'm going to remove that center point. You can just click on it, hit delete. I'm going to click OK, and now we can see that color showing up. And if I zoom out, we can see it's a very jumbled looking function, and that's one of the reasons why I don't like using the straight lines, just because it's a lot easier to organize when you're working with non-straight lines. And you can kind of position things the way you need to. And of course you can always turn off some of these values if you don't want to have them show in the graph if they don't really need to, or if you're not modifying them anymore and you just kind of want to leave them. Basically, these texture maps we're going to keep about the same. We really don't need a preview of them anymore, so we can collapse them. And then we have this other projected texture map. I can go ahead and I can collapse that. And I'm actually going to bring this fractal node back because we do want to be showing that. But we know what our image maps look like, so we can keep those basically the way they are, just in the collapsed mode. And let's take a look at that with this color change now, where we have more of that green rather than that brown color. And I do want to modify the overall scale and bring that up to 1, at least 1, maybe a little bit larger, just because some of those image map sizes might not look correct, and they might have been a little too small. And we can really see the saturation values on some of these lower parts changing. Pretty neat looking overall. Go ahead and close that out, and we're going to go back into the function editor. And we'll take a look at more of those color corrections. Because we have the Hls Shift, but let's change this. We can use the brightness function. And of course, a lot of these values are now disconnected, so we can just remove those from this current function. And I'm going to move down some of those input nodes on the top and just keep it kind of organized. And it's always a good idea to keep everything organized, especially if you're working in a production house and you're going to have other people working on the files, because you don't want to have something that's just completely ridiculous when they open it up, and you don't want it to be very difficult for them to edit. So we can use the brightness function and lower that overall brightness, or increase it and get some really neat effects. And that's pretty straightforward. Bring that to contrast, reconnect that node, and now we can adjust the contrast, and we can see those colors really coming out, a lot of graininess because of it once we get into those really high values. And bring it down, and we're going to start to see loss of color and change of color, really depending on which color you're working with. We also have the filter option, which is a really cool one. And this way what we can do is define just kind of an overall color that we'd like to change it to. We can go to blue, and now we have that blue filter color kind of overlaying it. And that's basically working in sort of the multiply mode that you would think of when you're working with other image editing programs, or even a lot of the node settings in here. That's basically just that multiply mode. Change that to a green, and of course the darker the colors, we're going to see very dark areas on the bottom, so we might need to increase that something a little bit brighter, and then it won't overwrite it as much. If we work with some lower saturated values, something kind of in between, then we get a fairly neat looking surface and good looking color. And then of course we can also adjust this filter color the same way we did just previously by using color map nodes or even texture maps. So if I wanted to have this basic shape and texture that we have currently, and also the bump being created from that, but I want to modify the color a little, I could even load in another texture map. And we'll go ahead and just load in another one from the Seamless Rock collection, something a little more red, and then we can connect our filter directly to that. So now we're filtering into a color of another texture map node. And in this case it kind of works almost as a combiner node when we have it connected like this. But we have some different settings available for modifying than we would normally have with a combiner node. So I'm going to remove that. We can go back, and we have a perspective color that we can set up. And basically the difference between our perspective color and our filter is that the perspective color will really only replace some of the darker colors that are available within this case, the texture map. And it's just another way of modifying the overall look. We can see when we turn that to a darker color that we're not replacing that overall look of those greens, and it's not turning black on the bottom like it did with the filter. Because like I was saying before, the filter works more in the multiply mode, where it multiplies the colors together. Perspective really just kind of removes some of the darker colors and replaces those, although you still get a really nice blend overall. And we also have, if we take a look, a color blending option for color correction. And you can think of this as the partial filter of color correction, where with the partial filter you set your filter and then the ratio, and with the color blending you set your color and then the ratio between the blend. So we can go ahead and connect that node back to that, and we'll set this to more of a yellow color, and we can see that showing up. And now we can adjust the ratio between whether or not we have the color on at all, and then of course a very increased value. And also both of these can be extracted and connected to other nodes. So I could even take our color and use the other projected texture map. And then our ratio, I could set this, we'll move over to the side, to our fast Perlin fractal that we have for part of our bump. And that could be part of it as well. There's a lot of different options you have by being able to extract all these parameters. There's even a color mask option. In that way, it will mask the color completely. So rather than blending them, what it'll do is set basically the color at 100% and completely replace the bitmap. So it's almost like you're just using an entirely different texture map. But different ways to modify that overall look. And we can take a look at the render for this and really kind of see what it's going to look like. Another thing I want to do is change this from the parametric mode to the standard mode, mainly because we've stretched this out, and I don't want that affecting our overall texture because of that. And now you can see the nice color blend between the two, where they're very similar because we're using the same sorts of maps to cover the color, although we still have those basically independent bump maps. And you can see the darker areas showing up because of the other texture that we're using, even though it's really not modifying the overall surface. So we'll go back into the function editor. And I'm going to delete just this color blend. And we'll go back. And I'm going to add another color map node. And we can take a look at some of the other options. They're fairly straightforward. And also similar to some of the filters that we have available. And so right now it's set to color blending like we had before. We could change this to gamma, and then we can adjust that overall gamma effect. And if you're not familiar with the gamma option, it's sort of a combination of brightness and contrast together in sort of a way. It definitely takes care of contrast values, but evens things out for the most part when you're working with values that are of course acceptable. Once we move to these really high values, you'll notice it pretty much turns black. So gamma can be something that's very touchy, but also very useful for darkening and brightening certain surfaces in a very uniform fashion. We also have the gain, and if we take a look, reconnect that, we can see how that evens out the material. But it's not always applicable to every single node you're working with. And one way to show that is by creating just another fractal node. Change our wavelength down to 0.2. And we're going to set our gain value to that. And we do see a slight change. And we do end up with a fairly neat looking surface because of that. But overall the effect isn't as prominent as you might expect, but it's really kind of creating some neat looking effects in there where we can see a sort of a grayer area. And it's just always a good idea to use all of these different color correction settings and things like that in order to create some realistic variations so everything's not completely uniform. And that will definitely cut down on tiling if you're using lower resolution image-based textures, and mixing those together with different procedurals will give you much more desired results when it comes to final output of your render.